Good morning, good afternoon, good evening, wherever you are. We're going to get started here in a minute. We'll give a few minutes before we kick off this community conversation. In the meantime, go into the chat. Tell us where you're at. Didn't mean to rhyme. Oh, look, there's people already knowing. Yeah, it's a bad sign when I'm starting to rhyme. Seattle, hey, Josh. Yeah, long time. Adam Riley, Austin, Texas. Peru. Yeah, wow. Yeah, I like your Saul, I like that Boston. Or Boston.
Yeah, we're excited today. Boston. Elongated.
Oh, I like Josh. That's if you rhyme, you will do time. Yes. Mark Perry, Portland, Oregon in the house. I'm in Bend. I'm surely not as warm as you. We were 17 yesterday morning. John, Rotterdam. Dinner time. Nice. Now we're gonna have rhymes going. Thomas.
Now we have riddles in the chat.
Tomas, Mercedes-Benz town. I'm trying to think which one that is. Dusseldorf? No. Sorry, not Dusseldorf. Sorry, I'm gonna get in trouble now. Not Thomas. Yeah. Berlin? Is it Berlin? Stuttgart. That's it. Joseph, Dearborn, Michigan. Wow, we're gonna have car. You're in another car city.
Uh-oh.
You guys want to have a little discussion? Which one's better?
This does not end well.
I'm starting trouble already.
Oh boy. Thomas coming in and dropping the Porsche bomb.
Yeah. Isn't that just a high-end Volkswagen? All right, maybe we should go on.
Maybe we should move on from car battles.
Absolutely. But before I get car aficionados all mad at me, don't need that. All right, well, let's get it started. Welcome to today's community conversation. My name is Sean Hurley, and I'll be your community host. We are joined by Jacob Small and Sola Moore, and today we'll be talking all things Dynamo. Actually, making Dynamo sing. I'm not taking requests though today. So let's kick it off. Hit that slide, please. Thank you, sir. Community conversations provide opportunities for engineers, designers, artists, and makers to meet in a safe virtual setting, to share expertise, get to know leaders in their field, and grow the community network. The sessions are always hosted and supported by Autodesk community managers to guide the conversation, feed important insights back from the community to Autodesk, and support participants in getting connected to the expertise they need. Let me give you some links about community conversations, as well as if you want to host one of your own, you are welcome to do that. We're always looking for new speakers and new topics. All right, some ground rules. Not really rules, they're just kind of a suggestion, and I've got the buttons so I can kind of make things happen. Everybody's line is muted to reduce background noise. We do invite you to turn on your background on your camera, just to kind of get a virtual kind of feeling that we're in the same room, at least digitally, and physical in this virtual world. The conversation is that. Let's try and keep it that. As you have questions, feel free to raise your little Zoom thumb or ask in the chat, and we'll get to you when there's a break. And anyway, that's again, conversation. Come learn something, ask your questions. The session is being recorded, and it'll be emailed to all attendees and uploaded to the session page. All right, the fun legal stuff. Sorry, I'm getting to go back and forth. Just a quick note. Any statements made, forward-looking statements that aren't in the shipping product, don't make any purchasing decisions based on those. Make it in the product as it is today. Dynamo is kind of a different animal, but still, anytime we have some of these things, we want you to be aware that the product as it is now is that you should make any purchasing decisions on. If Jacobs tells you that Dynamo is going to go fully AI and generate music, don't make your purchasing decisions based on that. And also, we don't know Jacob's taste. It could be Swedish hardcore metal.
It would be.
All right. Introduction. Let's go. Let's get into the good stuff.
All right, so I guess I'll introduce myself now. So my name is Jacob Small. I'm a designated support specialist focusing on generative design and BIM out of Autodesk Boston office. I spend way too much of my free time on the Dynamo BIM forums and interacting with users out in various aspects of social media. So I really enjoy getting to meet new people and find out all the different cool stuff everybody's doing with Dynamo.
Kia ora, everyone. My name is Phil. I'm the product manager for Dynamo here at Autodesk. I've been here just over 3 years now. Ex-architect back in the industry and from New Zealand, if you can't tell by my accent as well. Albeit it's a little fusion these days, given I've lived in a few different countries now. But very happy to be here today and talk to you. I describe myself as a curious human being and am based here in Boston on the East Coast. Awesome. So without further ado, let's kick it off. We're not actually talking about singing today. Sorry for any misdirection that we may have put out there into the sort of the ether sphere. We're talking about how to make Dynamo perform a little better and what you can do about it. And we'll briefly touch upon the things that we on the Dynamo team have to do about it as well as we go through this. So we're going to have a presentation. It's going to last around about 20 minutes as per usual. Sometimes they're a little bit longer, sometimes a little bit shorter. And then a live demonstration from Jacob as per usual and a Q&A. But please, if you want to talk to us throughout the whole conversation, we do want this to be a back and forth and engaging. It doesn't have to wait till the end. If you've got a silly question, just whack it in the chat or put up your hand like Sean said. Awesome. So what we're going to cover first is like what actually takes system resources inside of Dynamo. So what you see on screen right now is the 6 things that do. So we have UI load up, we have compilation, we have node execution, marshalling, tessellation, and rendering. So this is a series of different things that you can affect some of, and some of the ones effective only from us on the Dynamo team. We actually make material changes to the program. So if Jacob presses a button, there should be some other things that pop up here. This is going to explain a little bit what the ones in salmon mean. So node execution is simply how long it takes each node to run. If you're familiar with TuneUp, maybe you've used this before and start to understand the aggregation of what that means and that some nodes take longer than others. Tessellation is the breaking up of surfaces into polygons. So we are able to affect that a little bit here, which is pretty awesome. And then rendering is drawing stuff in the background, 3D preview. So depending on what your graphs look like, you might have actually noticed that the graph is going to execute before the rendering is done. So there's a little bit of a delay there. Sometimes, most of the time, it's instantaneous. And we're going to talk about some of these sort of settings that you can affect in Dynamo today to improve your life and make it go a little bit smoother. So if we move on to the next slide. So we're going to talk about some of the settings. Most of these are going to be effective under the settings menu in any version of Dynamo before 2.12. So Dynamo 2.11, 2.10, 2.9, and backwards and to antiquity. You'll notice that we have a settings menu, and that settings menu contains most of the things we discussed today. If you're using Dynamo 2.12 or 2.12 onwards, we've moved this into the preferences panel for the majority of these settings that affect sort of like the global state of Dynamo. So the settings are going to be basically the same thing. We haven't changed almost any of these settings as we move forward. So what stands today is going to still stand true tomorrow. So when we're talking about particularly render precision, so this is the drawing aspect, the rendering aspect, drawing something in the background 3D preview, you can affect this by render precision. So in the upper right, we have the lowest render precision, and the lower right, we have the highest render precision. This doesn't actually look that much different. Obviously, the top one's a little worse than the bottom one, but if you change this down to a lower render precision, especially in large scale graphs, this is going to have a noticeable difference in the rendering time of the geometry preview in the background. So if you're doing something very, very, very complex, then I would suggest you use it at the lowest state when you're iterating, because you just need to get an understanding of your geometry. And then you move it back to the higher state if you want to do, say, a presentation graphic coming straight from Dynamo.
All right, next thing that impacts speed is preview bubbles. So when speaking computationally, really you want to sort of think about what happens when the computer needs to do something. So if I want to interact with something, if I want to scroll through a list, or if I want to display something, it either has to be calculated when I ask for it, or it has to have been stored somewhere for me to sort of pull from it. And preview bubbles are something that basically, if the node takes 30 seconds to run, you're not going to want to click that preview bubble and then wait 30 seconds for that information to show up. You're going to want it as quick as possible. For that reason, the data basically has to be stored somewhere in some form of memory. Maybe not necessarily on the RAM, it might be on your scratch disk or somewhere else, but it's gotta have been written down so the computer can basically pick up the paper and display what it was that you were after, as opposed to having to do all that math from scratch. Preview bubbles are an excellent example of, let's store that in memory and pull it up when it's requested, right? So the problem with these is the scope of really big graphs is we put lots of nodes on Canvas, or nodes that have lots of lists or nested lists or lots of data. If you were to try and take the entire contents of the Shakespeare's Romeo and Juliet and try and pack it into one Dynamo string node, it's going to take a long time to display that preview, right? Because that's a lot of data. So the less you display, it's less of an issue. But as you get to those bigger graphs, you may want to disable those preview bubbles. Now, there are some trade-offs here, right? It will make things faster if you disable those, but if it's something where you're going to have to sort of go and enable that and then rerun the graph so you get the data back and then pull that content out of that preview bubble, it might have been sort of preemptive to shut that down to gain that speed boost. So what I actually recommend doing is leaving them on when you're doing your initial authoring, right? And when I do my authoring, I don't work in the live data set, right? I'm going to take a small sample of that data set, save it out to a separate file. This is going to keep you from accidentally putting stuff in the file you don't want as well, or you don't have to worry about crashing or work sharing operations as you're repeatedly grabbing content. So take that separate data set, make it a small sample, author your graph there, get ready to run it on the big one. And when it's time to run the big one, go ahead and disable the preview bubbles before you open that data set. Then when you go and run it, you'll get that benefit of the preview bubbles being off in terms of the runtime, while simultaneously being able to sort of maintain that functionality of one aspect at a time. Question in the chat from Thomas, which is kind of timely. Sol, do you know, is the preview button setting saved in the DYN or is it a Dynamo setting? I'm 90% certain it's a Dynamo setting because of an issue I had with 212 recently, but yes.
Yeah, I'm 99.9% sure it's a Dynamo setting.
All right, so we're going to go with yes, it's a Dynamo setting, not a DYN setting.
Yeah. So something else we can affect is some optimizations, not necessarily just from the settings menu, but also from nodal menus or nodal options. So in terms of rendering, like we discussed previously, it takes resources, like Jacob said, to do things in any computer program that you use, no matter what it is. And rendering in Dynamo also uses resources. So if you choose to turn off the need to render some things inside of Dynamo, then the system doesn't have to consider it. And if it doesn't have to consider it, it doesn't have to use those resources. So turning off the node preview of geometrical nodes, that you do not need to see, sort of say all that geometry in the background preview, maybe you only want to see like the final piece, like the end result, is actually going to save you time as well. So all of this preview geometry is going to be rendered on every single node by default, providing it has geometry to render in the background. And so if you don't need it, simply get used, so turn it off, and that is going to give you back some of that resource. It will just not consume that resource in the first place. And this is going to result in less rendering, which in essence is going to result in faster results or faster graph execution at the end of the day.
Now, just like geometry can take a while, the rendering of the labels associated to that geometry has a pretty big hit too, right? Now, unlike geometry though, oftentimes it's really helpful to have those capable to sort of enable them as a debug feature, right? Where we've got multiple sets of geometry on top of each other, you can't really use that to debug until you get down to just the one piece in many cases. Whereas with labels, even when your geometry is on top of geometry, they can be super, super handy. So this is another one of those aspects where I, again, like to sort of modify that setting as I go. So effectively what this feature is you can select the individual node and it will highlight all the geometry that node is interacting with in the background. And with the show labels option enabled on the node, this is a per node basis, you'll actually see the rank of that individual object within the larger structure of data. So you can highlight everything that's within a particular subsection of a list of geometry, all the geometry, or individual geometric elements. That makes it extremely useful for figuring out which is the index of the geometry or which is the geometry at the index that's causing the warning or causing the error within the larger context. So this, again, feature can be disabled by right-clicking on the node and saying, disabling the show labels button. Now, again, because there's some authoring capability here, I do recommend sort of leaving that on as you're getting going with the initial authoring of the graph. But once you get to the point where I'm past that, I'm not going to have to come over here again. And when we disable that geometry preview, you probably want to disable the label at the same time.
Yeah, so just adding into the previous slide very briefly, like those labels are also quite memory intensive to render as well. It has to understand where they are, it has to understand the orientation towards the camera, has to understand basically a double up for every single label for every single piece of geometry. So turning them off is quite significant in large geometrical data sets. All right, so talking about freezing. So most of what we've talked about so far is mostly orientated towards rendering right now. So rendering taking resources. Another thing that takes resources is sort of tessellation and the actual performance of the graph itself. So if you don't want to tessellate some geometry and you don't want to actually execute some of your graph, simply freezing it is going to tell the virtual machine inside of Dynamo to essentially ignore that entire portion of the graph that starts at the node that you freeze and works every single thing downstream from that point in time. So this is going to be shown inside of Dynamo by having this dashed outline where we're changing the way preview looks when we do our visual refresh, which is coming up in the not too distant future. But currently it's going to be a dashed outline and everything's going to be grayed out downstream from that node point. And this can be used when you're working through and building a graph data set, when you only want to sort of calculate or execute pieces of your graph, but you don't want to sort of disconnect them. It's another way to essentially put a stop inside of your graph, and you can understand how to execute just a portion that you're iterating on, providing that portion is more upstream from the portion that you have frozen downstream.
All right. Next piece, and this, I'm super excited that I get to present this because this is probably my all-time favorite feature of Dynamo Sandbox. I've been raving about this since the day I figured out that it was a thing. So really excited to show it to everybody. But basically the UI and engine threading of versions is different. And what do we mean by that? So in Dynamo Sandbox, you can basically break content up into multiple threads. And the reason for that is Revit and Civil 3D and most of our sort of core, more popular integrations are single threaded in terms of how Dynamo works. Dynamo basically has one processor to do all that work. So if you say, hey, Dynamo, go run this graph and do this work, right? And run all the calculations to populate the data that goes into the memory and is displayed in the preview bubbles and the geometry and everything else. Dynamo takes up that thread to do that. And so as a result, you can no longer navigate the UI. You cannot make any further inputs into Dynamo because the thread's already busy, right? That worker's already tied up. Whereas in Dynamo Sandbox, the user interface and the execution are decoupled, right? So we now have two different threads that we can work in. So we can have one thread doing the actual execution of the nodes and the other thread allowing us to get some work done. So what does this mean for you as an end user? Well, if you ever have a graph that takes a really long time to run up front, but you sort of want to be able to start making some edits on the back end, it's not hit run, go get myself a cup of coffee, come back, sit down, and then start making those changes. Instead, you can hit run, scroll to pan to the end of the graph, put the new nodes that you wanted to put on canvas. By the time you're done making those authoring changes, the graph hopefully will have finished running. And then you can sort of hit run again. And the only node that's going to have to re-execute is the one that's had the change because everything else has already been serialized into memory, right? So this means we can continue to progress along without any of those, wait, now we have to run the whole thing, which is huge. Another great example, if you've ever put yourself in an infinite loop using Python or design script, I tend to do this once a week when I'm trying to demo these things live. Within Dynamo Sandbox, you can quickly hit save because that content will allow you to save because the user interface is still active. So even if it's like, hey, this looks like it's going to crash, you can do a save as. If you made a change, do a save as, whatever it may be, and you can keep up with that, which is huge. Now, if all of that sounds really great and you want to start to take advantage of that, we've put some basic instructions on how to get Dynamo Sandbox on your system up here on screen in the bottom left corner of the slide here. So you can go to dynamobuilds.com, find the version that you're after, download that piece. It will come down as a zipped folder. You want to make sure you right click on that folder and unblock it before you extract it. Otherwise, you're going to have a lot of troubleshooting to do after the fact. So just go ahead and unblock it before you unzip it, or use 7-zip to do your extraction. Once that's there, you can put that extracted folder anywhere. You can even run it off a thumb drive, a USB drive, whatever it may be, and it will run directly off that location. It doesn't have any interaction with the registry or anything like that, which makes it really great to be able to sort of quickly move content back and forth. The way you launch it is you just navigate to wherever that content or wherever you extracted those files to, find Dynamo Sandbox.exe, double click, and you're up and running. The one drawback to this is you will have no interaction with your integration. So if you need Revit data, you're going to have to be in Dynamo for Revit. If you need Civil 3D data, you're going to have to be in Dynamo for Civil. Little tip, you can use the data.remember nodes from the generative design package that comes with generative design to Revit to sort of resolve that and enable some of those features and get into that sandbox authoring environment if you're really clever about it. But that's perhaps a topic for another session on another day.
And a couple of added things is, if you're like Jacob or myself and you have essentially like 10 different versions of Dynamo Sandbox that you play with or use on a daily or weekly basis, we do right click and send the Dynamo Sandbox.exe to our desktop and rename that shortcut to say Dynamo 212 or Dynamo 210 or whatever the version may be, which helps. And another really cool thing about the engine and UI separation is for people like me who are OCD about how things look, you can go and clean up the way your graph looks and add notes and add all of that good stuff while your graph is actually executing in the background if you're using Sandbox with the multi-threaded approach. And that means you can kind of do twice the work in half the time in some instances. All right, so node preview. So we touched upon this a little bit previously, but one really interesting way to potentially get around this is using kind of a show me stuff node, so to speak. So what I usually do when I'm building graphs that are somewhat geometrically complex is I will use a code block. I'll just give it any variable, maybe preview, maybe just an X if I'm feeling a little lazier. And I'll use that to walk down through my graph and have everything turned off in the background, just to ensure that I'm only looking at the relevant information at any point in time. So it's kind of only showing what the result is of the final node. And this is also true and representative of the data that flows through as well. Instead of using a pinned preview bubble for every single node that comes, you can just pin the preview bubble of your code block and see the data that flows through too. So this simply shows the end result. It only renders the set of geometry that I'm telling it to render, which can increase the performance of your graph.
All right, the next thing that can impact performance is Boolean operations. So typically, I recommend avoiding Boolean operations when possible. Effectively, Boolean operations, regardless of which software program you're in, are notorious performance hogs. They take a long time to do those sort of solid interactions. What's it mean when this solid is subtracted from that solid, or that solid is added to this solid? What's the union, the overlap? Those sort of features, slow, but extremely accurate. So there's a lot of value to them. Now, one sort of tip and perhaps an exception to that rule is you can disjoin, or you can join up disconnected solids into a single solid to reduce the amount of sort of testing that you have to do if you wanted to check for, do these two items intersect, or if you wanted to iterate over all the things in this list to find out if that condition is met. Instead, you can combine everything into one particular list and then test against that list to save yourself some hassle and some depth in your list and ranks, right? One test against the disjointed solid is going to be faster than 75 tests against, or in this case on screen, 25 tests on many, many tiny solids. So try and keep that in mind as you're building content through. Similar results can be found with surfaces. If you have a lot of surfaces and you want to know, are there any trees inside any of the buildings I just generated on site? You can combine all the buildings into one poly surface and then say, do any of the points for the trees touch the poly surface, as opposed to having to say, this one building, 75 trees, do you touch? No, this next building, 75 trees, do you touch? So keep that in mind and simplify those lists where you can through those geometric operations.
I've got a couple of questions in chat as well before we jump too much further.
Yes, so, I was typing up one to Adam. Adam, the Revit API will not allow you to access any of that data from out of process. This is entirely just to prevent sort of contamination of the file from multiple pieces coming into the threads at once. Civil 3D does have a few ways around that through AutoCAD. I believe it's the COM API that allows you to do that from out of process, but it's much less stable than the standard .NET API that you can get to in process. It's much slower as well.
The exception to that is Revit IO. So you're able to do things via sort of an out of process API inside of Revit, but that is still not encompassing the entirety of what is possible in the Revit API to date. And then in terms of Dynamo hooking up to Revit IO, we're looking into that in the future. But the caveat here is that Revit IO currently doesn't do any UI stuff. So if we're talking about like Revit nodes that want to collect something from the current document, there's currently no connection between the current document and sort of Dynamo's integration. So you wouldn't be able to reuse a graph that you're using today in Revit IO. You'd have to sort of rebuild that graph to sort of collect things in a different way. But we are looking into it. We do see a lot of power in that, and watch this space for the future as we figure out those discussions and see the value and the worth in it. When it comes to Paulo's question, talking about Dynamo crashing out and taking along with it, that is painful for sure. Jacob and I experienced that pain as well along with you. The way Dynamo currently works, like Jacob said, is it's in process, which means like when there's a crash in that process, the whole process comes crashing down. So we've talked about potentially doing an out of process version of Dynamo, which means you could have the UI and the engine in two separate places, but the engine still has to be inside of the process of Revit, which means if the engine crashes, then Dynamo is still going to crash Revit in the background. If the UI crashes, then that would sort of solve some of those issues. But unfortunately, I think most of the crashes that occur inside of Dynamo for Revit are more at the engine level as opposed to the UI level. So that would not necessarily solve the bulk of the problems that exist today when it comes to that. But Revit IO, for example, as that gets sort of bigger and more deep and more rich over the years, then that is going to be an interface that we can use that has a separation between Dynamo and Revit, which means if Dynamo crashes in that particular case, it's not going to take Revit along with it because there's an interchange or a barrier between Dynamo and Revit, and there's just data being sort of thrown across the fence between the two applications.
There's another question in the chat from Luigi. Why other Autodesk softwares like Revit are not multi-threaded the way Dynamo is. So Revit actually is multi-threaded in many ways. And if you look at Revit compared to other commercial CAD applications, the multi-threading is actually pretty similar, if not sort of a one-to-one comparison. Stuff like opening files, displaying your view, saving your model, auditing, purging, expanding elements, that sort of stuff is all actually done on multiple threads at once. It's the actual input right now that's mostly limited to sort of the single thread, and why, as Sol just mentioned, much more eloquently than I could ever attempt, why if Dynamo comes down, Revit tends to go with it.
Right. And then Thomas is asking, is it possible to reduce the precision to make Boolean operations faster? Good question. Don't actually have an answer to that one. I don't think so right now. Like you can reduce the rendering precision like we saw in a previous slide. You can't, and the tessellation, I don't believe actually we offer any option to sort of reduce tessellation right now. That is something that is an interesting point and something we could look to in the future to try and improve for sure. All right.
Speaking of tessellation.
Yeah, onto tessellation. So as we sort of touched upon very briefly in the first slide, there's this notion of this thing called tessellation, which is the breaking down of surfaces into triangles. And so creating a piece of geometry and drawing it are two different events. Funnily enough, drawing it actually takes more resources and takes more time than creating it. So tessellation is faster than rendering. But still, removing some tessellation steps from our graph, like we saw with turning off some of the previews, is a step in sort of improving the speed or the efficacy of our graph as well. So every single node that is out of the box inside of Dynamo right now that is geometrical in nature is always creating tessellation, tessellated geometry. And so one way to get around that is to create your own custom nodes, sort of through zero touch or using Python and making sure you sort of release those system resources. We actually did some work about 3 or 4 releases ago to automatically do that in Python for you, so you don't have to manage that anymore, which is pretty cool. But untessellated geometry can be achieved through sort of this collecting of different steps into a single entity. And what that means is you currently can only do that in C#, zero touch nodes, or Python, but the final result that you actually return back into the graph space is the thing that Dynamo is then going to tessellate. So this is going to increase the performance speed of your graph if you want to sort of bundle geometrical operations into a single entity.
Next up, we got host geometry. And it's important to note here that many aspects of host interaction are going to be faster directly in the host than they are in the sort of decoupled Dynamo engine, right? Because you don't have to worry about that marshaling of bringing content from the host application back down into Dynamo. But effectively, Revit is going to do sort of geometrical operations, right, with the Revit element much faster than Dynamo in the context of Revit. Right. So if you can call that Revit API directly to manipulate that piece, such as if you can build the vector that you want to move the element by, and then just element move by vector, as opposed to element get location, element set location, move by vector is going to be a good amount faster in that case. So the other aspect here is to make sure that you're leveraging instancing to populate large amounts of data relative to the same object. So if we wanted to place 100,000 trees, such as we've seen here on site, you want to make sure you're placing a family instance repeatedly, as opposed to baking the same geometry in a slightly different location over and over and over again into new pieces, right? That the same process that applies for best practices in Revit still applies, even though you're able to do it through Dynamo. Also, it's really important to make sure that periodically, in particular when you're authoring in the Dynamo environment, that you're restarting Revit or Civil 3D, whichever one it may be that you're in, periodically to sort of free up those system resources. Also, and I say this probably not as often as I should, but way more often than I feel like I should have to, make sure you're restarting your computer at least once a day. Don't leave your computer on for 2, 3, 4, 5, 6 weeks at a time. It just frees up so many resources, and everything will be quicker if you just take the time to shut off at the end of the night. Anything to add, Sol?
Case in point. Yeah, case in point. If I don't restart my machine every Monday, so like at least once a week, then my Zoom doesn't work. Like literally just dies. So there's certain things that are going to be on your machine that are very much going to benefit from a restart. I would also add that you can use things like points inside of Dynamo as like the location for family instances to place back in Revit, and that's going to be much faster than doing sort of more complex geometry. One other cool little sneak peek is that for Dynamo 2.13, we have a few different rendering performance instancing pieces of work coming into Dynamo, into the program. That means you can now actually render things like 1 million different spheres or 1 million different points inside of Dynamo and have it actually work. So this is going to be only using instancing. So if it's the same piece of geometry, so a point instanced up to 1 million points is the same piece of geometry, essentially just put in different locations. For a sphere, you're going to get those performance gains. So that's a little sneak hair, maybe not a sneak peek, but I don't have an image for that. All right, geometrical power. So this is not so much a performance or a rendering or a tessellation piece that helps, but it is something that I think is important to add. And so as we touched upon Boolean operations earlier being really like sort of memory intensive, so computationally intensive, they're also extremely, extremely powerful. So there's going to be a lot of instances where you're going to want to use Boolean operations because of the kind of results they can give you. And it allows you to create incredibly complex solids. So Dynamo's geometry kernel has a really, really, really robust solid modeling capability. So it means that you can generate or combine or Boolean a bunch of different things together to get some really interesting results. So this is just a silly little example on screen right now, but you can start to get some really complex geometry by doing a lot of slicing and merging operations when it comes to pieces of geometry inside of Dynamo, and you can Boolean on top of other objects that have already been Booleaned out. So again and again and again, you can keep going. And because Dynamo uses Delta compute, which means it's not going to recompute any node that doesn't need to be recomputed, you can do this through sort of a sequence of actions, which means your graph's not necessarily going to get crazy in terms of performance speed if you've already run it at least once.
Next up is memory use. So you can find that you're going to run into a bit of a memory bottleneck if you sort of allow too much geometry to accumulate, right? And this content basically, it stacks up over time, right? And so we mentioned this before, and maybe I jumped the gun when I said make sure you're restarting Revit periodically, Dynamo periodically, shut off your machine once a day. All of that stuff will help to sort of free up those memory resources, because when you start the machine back up, all the memory is basically available at the initial push of the power button, right? Also, it's important to note that mathematical operations in general are actually their entirety are going to be much, much faster than geometrical operations, right? So you want to try and sort of stick to leveraging that content in mathematical terms as often as possible to just sort of reduce the overall complexity. So to that point, and I think we're going to talk to this a little bit more on that next slide, try not to use solids or meshes until you absolutely have to. Keep stuff sort of simpler and closer to the mathematical end of things whenever possible. Also, you can probably want to make sure that you're using C# zero touch nodes or Python nodes whenever possible, just to take advantage of the disposed geometry to keep that content from piling up in the memory over time.
Cool. So if you came to Yordisk University when Jacob and I presented that, the next two slides are shamelessly stolen from the work that we presented there. So they're going to be a little bit different to what you've seen previously aesthetically, but what we're talking about here is sort of abstract versus model geometry. And as this GIF sort of cycles around, you're going to notice that there's going to be a performance difference or variance between abstract geometry usage and this exactly the same end result graph than there is by using geometrical operations. So it's about a 43 times faster on this very small graph by using abstract types than it is to use geometrical types. And so because this is a very simple graph, it's all still executing in around about a second, which doesn't make, around about 1/10 of a second, sorry, which doesn't make that much difference. But if you think about the scaling application to those, and you think about if I've got a really big graph, the difference or the 43x difference between these two approaches is going to be magnified many times over. So small scale does not equal large scale. Definitely lean into the abstract types if you can. It's going to make your life a lot easier. They're a little bit harder to wrap your head around initially because this is mostly sort of vectors and math stuff. But if you do wrap your head around them and you start to leverage them and use them, then you're going to find that your work inside of Dynamo is going to be faster than if you're just going to use geometrical types.
Next up is reducing your trips to the well. So effectively, you can imagine if you were going to fight a fire, you wouldn't want to do so with a beach pail, right? You don't want to go to the well, dip the bucket in the water, and then run to fight the fire. You want to bring all the water you can at once, right? So anything that you're going to need to grab, if you want content that you want to sort of leverage in the future, let's say you wanted to renumber all the doors in your project, right? All elements of category doors. And you might say, oh, you know what? I want to renumber my interior doors this way. So you might filter out interior doors or filter out exterior doors, whatever it is. Don't go back to the well twice. You want to make sure you're going and doing the all elements of doing the selection once and querying information about that object rather than starting the process over and over and over again. And this is true not just for sort of interactions within Revit, but it's also true about geometry, right? If you've built a whole bunch of coordinate systems and you're going to sort of use those coordinate systems to populate points that you are then going to use to generate lines, might as well use those coordinate systems to, generate the lines once and then apply the lines to the coordinate systems rather than moving the points and then generating those lines, right? Leverage the instancing capability of the geometry that you're building up to sort of allow you to get those speed benefits. And I'm in the wrong, there we go.
All right, and our final slide today before we jump into a live demo is talking about sort of topology versus geometry. So another way you can start to work in a slightly more efficient way or a faster way is by using non-manifold geometry, which is topological aspects. And this is faster than manifold geometry, which is more of the physical geometry that you sort of think about using in Dynamo for the most part. So topology is lightweight as geometrical representation. We're talking about things like edges and vertices and this kind of stuff. There's a bunch of different things core out of the box using topology tools, or you can also leverage other packages. Things such as Topology does a really awesome representation of how to start playing with and working with topology. This represents, like I said, faces, edges, vertices, wires, shells, this kind of stuff. It's this representation of the physical entity or the physical reality in a more abstract term. So if we talk about, again, the abstract versus geometrical types, topology sits in the abstract category. And then you can convert that topology into geometry. So you can convert a face into a surface, you can convert an edge into a line, you can convert a vertex into a point, and so on and so forth. You can also use things like Dynamo Shape, which does really amazing things. This also leverages representational geometry to do those things at speed. So when you see it being rendered in the background, this is rendering more topological aspects than real geometry. And then you have to physically convert that back into Dynamo entities if you want to use that downstream. It just means it's infinitely faster to get some really complex representation of geometry in the graph space than it would be by using real sort of manifold geometry, which requires knowledge of other things. It requires a huge amount of understanding when it comes to working up and downstream in the hierarchy trees.
Awesome. Well said, Sol. All right. Let's cue up that danger music and get started with that demo. All right. So I have here a graph, and I hope your graphs are much better organized than this. I did take some time to get this a little bit better looking, but anytime I start to see stuff that looks like a really cool pattern in my wires, I get a little bit nervous, but in this case, I'm not stressing it because what we're after here is trying to figure out how long different operations take, because this session is all about making Dynamo go quick, and we want to sort of understand what that process is. So what I've done is I've made 100 times 3, so 300 different random numbers that I'm going to use as X, Y, and Z values. And these are going to be used to generate, in this case, 100 surfaces. If I wanted to simplify that number, we can go ahead and we can set that down to 10 for now. We'll run it, and then I will eventually be making 10 surfaces instead of 100. I'm going to keep this number a little bit high, though, because we want to make sure that we're stressing the system just enough before we really click go. So we talked about a few different things in terms of performance in the session today. So most of those are available up here in the settings menu, right? So if we wanted to look at turning off preview bubbles, so on and so forth, I think someone had mentioned, is there a way to turn off geometry from multiple nodes at once? There is. You can select them all like this, right click on the background, and then say hide all geometry preview, and that will disable all the geometry preview for those individual nodes. Or again, you can right click on the node itself and say, turn off the preview. But in any case, since we want to talk about speed, what we really need is a way to evaluate the speed of execution. For that, there's a handy view extension called TuneUp, which is available in the package manager. To get to that, you're going to click up here and say packages, search for a package, and then search for the view extension TuneUp. Once you get that downloaded and installed, you'll see something like this. Within TuneUp, there's a few different pieces that are really key. We can sort the nodes by the number that they were executed in right over here. We can sort them by name by clicking here. We can sort them by execution time here. And what's great about this is I now know which of these nodes that executed took the longest time to run, right? What we can do is we'll hit force re-execute right up at the top here, and this causes our entire graph to re-execute. Every node that I have on canvas has been modified. And if I add new nodes to the canvas, if I put a new node on canvas, notice that one popped up down here. When I hit run, that node is now executing up here. And we can even go through and we can find out where different nodes are by just sort of clicking on them, and it'll allow us to sort of quickly cycle through where content may be. So if we find that node that's slow, this one executed in 10, that's the biggest number on here. Where is it? Okay, it's a multiplication node in a code block. Still super fast, that's 10 milliseconds. It's not even worth thinking of as a fraction of a millisecond, right? So now that we've covered what TuneUp does, let's start to look at some impacts of speed on different graphs. So I've built up basically this sequence of nodes where we're going to create a point from those different XYZ coordinate sets that we have. Again, it's 300 coordinates for X, Y, and Z. We're then going to chop that up into lists of 3, build a polygon from each list of 3 points, and then create a surface from those nodes. So I'm going to go ahead and I'm going to unfreeze this node, and then I'm going to hit run. Notice I now have these nodes that have executed up here, all prefixed with those zeros, totaling 216 milliseconds to run this section of the graph. Whoop. All right, so that section as a series of nodes for the 100 pieces took 216 milliseconds to run from scratch to end. I've then taken those nodes and I've created another version of them. I'm going to unfreeze this and we'll go ahead and we'll hit run. And this one took 139 milliseconds. Right? And this is effectively what I do when I'm sort of building up the content. If I know speed is a big concern, if I'm going to be sending something to generative design, and this graph is going to have to execute a minimum of 100,000 times every single time we run it, we want to get these pieces down as quick as we can. Do a little bit of trial and error. What's it like to run it as design script instead? There's a time savings right there, right? And we can again force re-execute and sort of look at what those end results are. I'm going to go ahead and show by name this time. So then I could just sort of tally these up. We're still pretty low right there. Design script 109, you know, we're pretty close in that in terms of the overall speed. Let's try this one now. We're going to look at it as a single line of design script. So I've sort of taken these multiple outputs, which means I've got multiple sets of information that have to be serialized into the memory, and sort of compacted it into a single piece, right, to sort of run more of that content in line. And then when we come here, we can look, that piece ran in 112 seconds. The other one ran in 92. We're within 10%. It's pretty much the same within the overall execution. And this can continue along, right? So now I've created a multi-line function where I took the code that I wrote as design script, turned it into a design script function, and just called surface maker. And then we can execute this. And I'm just going to hit run this time. And that's 139 seconds, right? And so we can continue to write these down. And I forgot to grab the time on this one. That was number 2, 112. What if we did these multiple lines in a Python script? This is using Python 2. Now we got something interesting here. This one ran in 1,658 seconds, and that is the actual execution time. It doesn't feel like it because we know intuitively Python should be faster, right? It's going to dispose of that geometry for me. It shouldn't have any of those issues. But what we're actually seeing there is Dynamo, before it can use that Python, Dynamo has to spin up the Python engine. It has to sort of call that content in. So the first time you run that Python node, you are going to take a little bit of a hit in terms of your execution time. This next example is looking at a single line function. So again, we took that bit of design script that I wrote before, returned it as a single value. When I force execute there, I meant to actually just execute instead of force execute there. That drops down to 113 seconds. And what's interesting, notice I did the force execute there, and then now the Python 4 is down to 126. So let's just make a note of that. The second time out, that was down at 126. And we can continue to basically perform this operation of freeze, unfreeze, 167 here, unfreeze, run. Python 3, big hit in terms of time, because again, this was the first time we had to open up that Python 3 engine. So there was a pretty significant hit in terms of that. But let's find out if when we run this as a single line instead of multi-line. Okay, 144. All right. Then we get into some custom nodes. So I took the exact same features that I had before, and I packed them into custom nodes. And we covered custom nodes in a previous session. This one ran in 960. Freeze this one, run. This one ran in 123. Freeze this one, or unfreeze, I should say, run. 101. $95. And all of this stuff that we're doing in terms of speed really will vary over time, right? So each individual sort of set of runs will sort of, the next time I run this graph, we won't get 109 here, or we likely won't get 109 here. We'll see stuff sort of very low and high just based on what your computer's up to when you hit that run button, some other stuff that's happening in the background, the nature of computing. But it should be relatively consistent with those exceptions of stuff like I pointed out on the Python nodes, that second execution of that Python 2 node was drastically faster because all the tools that Dynamo needed to leverage Python were already in there. I'm going to go ahead and I'm going to do another force re-execute so we can start to have a look at this once again. And you can notice all that content sort of filtered up. And now let's go ahead and let's look at which of these was the fastest. All right. Custom node only, one out. So this one ran out at 800, or was slowest rather at 859. And our fastest complete was multi-line of design script, right? But that's pretty close to multi-line definition and custom node of Python 2, inline design script. We're talking pretty narrow results. Next thing I wanted to sort of illustrate here is what if we made more? So if I increase this and execute that graph, now instead of making 100 surfaces, I'm going to make 1,000. And let's actually look at what these surfaces look like. We're going to go ahead and turn on the preview for this. And this can take a while, but notice what I was able to do there. Even though Dynamo's calculating all those surfaces, because I'm in Sandbox, I'm not in Dynamo Revit or Dynamo for Civil, I can continue to navigate this space, zooming in, zooming out, making changes to nodes. I could start typing new code if I wanted to, but you can see how this content worked out. So now we'll sort once again by execution time. Our slowest node method was custom node of just nodes only, right? And our fastest complete node method was custom node of multi-line definition at 1,000 milliseconds, right? And all that content runs through. And if we start to generate sort of multiple values of this, it is some perhaps fancy art that you can sort of see that content. So as we sort of preview these different contents, you can see that lag that sort of happens between when I'm able to start running the graph and when the results actually come through. Let's go up one more order of magnitude. I'm really pushing the limits of my system, being on a Zoom screen share, sharing my audio, and I'm about to hit run on all of this code that previously took about 28,000 milliseconds to run all the way through. But we're going to let that sort of process itself and watch right down here when this run frees up and the run finishes versus when the geometry preview updates itself. You'll see that there's oftentimes a pretty big lag in between those two numbers. The other thing that's worth noting in TuneUp is you see these sort of individual instances. This is the order in which they finished execution, which can be sort of handy to know. They do vary in between Dynamo runs. We probably wouldn't see this one come up as number 10 consecutively. But these are some pretty big numbers in terms of overall speed. Might not get this one to finish within the confines of the demo, but let's check the chat. Anything interesting happening in there, Sol?
Yeah, lots of Q&A happening. So I think we've been answering most of the questions that come through. So one thing to reiterate here is that these numbers are not 100% true, right? Like Jacob said, they're going to bounce around slightly, and every single time you execute a node, that's going to be true of that node. Like Jacob said, it depends on machine resources. So if you're the kind of person who has Photoshop in the background, notorious performance hog, if you have Revit open in the background, you have a bunch of other things open in the background, then this is probably going to be a little bit slower. And if you have a fresh machine, you've just restarted, you just spin up Dynamo and you run this graph, it's going to be faster than having all of these other machine resources sort of dedicated to other places. So, you take these numbers with a grain of salt, but they are relational to each other, and the bounce around is going to be very minor. So we're talking like sub 5–10% in terms of change, and even less, like 1% change bounce around in these, especially when you get into the larger numbers. A 10% change at the sort of 64 millisecond range is going to be not noticeable at all compared to sort of a higher one, but you're not going to get a 10% change when you're talking about 20 seconds to execute. You're going to be still talking about sort of millisecond differences here. So it's not a percentile scale problem necessarily.
Yeah, I've gone ahead and started up another Dynamo Sandbox instance so we can have a look at a few more things here if there's desire. Whoop, I meant to open that speed testing demo again. And we're going to make sure everything's unfrozen as it was before. I'm going to set these numbers back down low. We'll open up TuneUp.
While Jacob's doing that, one thing to bear in mind is that TuneUp is still technically in beta as it is a package right now. If you have a really complex graph, it might start causing performance issues of itself. And that's partially because every single node now has to have a profiler attached to it, which means every single node now has to track the time it takes to execute. So there's going to be a performance hit by using TuneUp. So when you're using TuneUp to sort of build your graph, great, but if you're going to just be executing that graph on your Revit model, your Civil 3D model, wherever you're executing that graph, don't use TuneUp in those instances, and you're going to get a bit of a performance boost as well. And then we also need to do some work to improve the sort of boundaries, the guardrail, so to speak, of TuneUp before we put it in product, because there's some sort of leaks when it comes to TuneUp's memory usage, unfortunately. So it's a great tool to play with and to explore what's going on, but definitely don't use it for every single thing you do if you don't need to use it.
Yeah, so now we can sort of see sort of the execution time on the 1,000 pieces here, and sort of walk down kind of the line. So this one was 1139, whereas before it came in at 139. So maybe there's some coincidence happening there within the numbers. Multi-line function number 3 came in at 1165. Previously, it was pretty well performing, right? Coming in, obviously, speeds relative to what we saw in Python, but now it's not performing quite so well within that larger context. So again, you can learn a lot about sort of performance, but it's important to realize that this is, to Sol's point, and my point before, this isn't as much of a science as it is an art form, with a little bit of experimentation with the way it goes in terms of how you write your code and how you build your graphs to be effective. All right, so we're down to the last 4 minutes. I think we've caught all things other than perhaps S. Hansen had the question on a large graph and running on a separate file. Interestingly enough, you actually have to close out of your Dynamo instance in Revit 2022, which should free up some of that memory when you swap between files. So if you close the active file, even if another file is open, it will basically force Dynamo to restart to do some of that free up of system resources.
Cool. So maybe we'll move on in the last couple of minutes to the next slide. All right, so next Dynamo sessions, we have a wrap-up session here coming up next. So there's one more session on December the 9th, 2021. This wrap-up is going to be a brief overview of all of the stuff that we've covered in 2021, and then a big Q&A, and everybody we're encouraged to come and just have a conversation, to be the most conversational community conversations yet to date. We'd love to hear what resonated with you, what you thought was great to learn this year, what's maybe a hole that we missed that you want us to cover in the upcoming year, because we do plan to release more super duper awesome content coming in February 2022 and onwards. And that content is going to start to get a little bit more specific and also potentially start to explore down generative design avenues as well. So if you want to hear something, come to the wrap up and tell us what you want to see.
All right, my part. I felt like I was at a node race or a horse race there. That was, and I was just waiting for Jacob's machine just to crater. And all of a sudden, Jacob disappeared from the Zoom call. I know it's kind of an evil thought, but anyway.
We did finish the larger execution though in the background there. So yeah, good things.
All right, we'll wrap up today's session with 2 final slides. If you're looking for other ways to connect and engage in the Autodesk community, we have some resources for you. Also, please don't leave yet. I'm going to also paste a survey, and that really helps us form the program in the future, and lots of good stuff like Saul said with 2022. We're already to 2022. So you can explore the many ways to connect in the Autodesk community, including the global network of user groups, our industry-focused communities, helping your colleagues solve business challenges together, the Autodesk forums, of course, and staying connected with us on Twitter. And there's also the Dynamo forums, right? So they're a special little thing. That's where Jacob lives. And let me paste that survey link for you. Just it's an easy, simple, easy lift one, but it does help us. So thank you very much for attending today. Thank you, Jacob and Saul. You guys are awesome. I learn something every time, and I'm inspired. And sometimes I can't reach as high as you guys, but that was awesome. So anyway, continue to stay connected And we hope to see you in the next Autodesk community conversation. And I'll post the videos either today for this session or Monday, because Autodesk is taking the day off tomorrow. We're pulling the plug and we're running. So thank you, everybody.
Thanks everyone for coming. Really appreciate you joining us today to listen to us talk about Dynamo not quite singing.
Thank you, everybody. It was a blast as always.
Catch you later.